Good morning, and thanks for being here. I was hesitant because I had about 4 different talks to present, and I was asking myself which one will be most suited for the occasion. But we'll try to talk not only about all these organizational things, CEA, Digital Ethics Committee, what is that? But we'll try to talk about actual difficult problems in digital ethics. So it will be mostly about research and not so much about structures, laws, and all of these things. But let's start with this kind of picture. So when, Sophie, can I move, or because of the Zoom, I can't move?
You can move a bit.
I can move a bit. Okay, yeah, good. So when you see this picture, and when I show it to people and I say, what kind of questions do you see when you see this? They all say, oh, here's a robot replacing a human nurse. We have a question of the evolution of professional work, right? So how is the labor market going to change? And then people see that this woman is watching the robot directly the eyes, and they say, oh, emotional contact. She's so happy. She does have emotions. But the robot, of course, only imitates emotions. So the question of emotional contact, and so on and so forth. And I say, yeah, of course, these are all the classic big questions of digital ethics that we have been discussing since the 60s. But there's something that I find shocking in this picture, and very few people see what is shocking here. I'm not sure whether you guys see what is really shocking. Not these big questions about the labor market, but look at the contact zone. Do you see the contact zone? There is a contact zone where her hand touches the robotic hand, and she's not even following that contact with her eyes, right? So, of course, this is a promotional picture, right? That's not how things happen in real life. But definitely there's an issue. She hasn't been trained, but also the designers of the robot probably haven't really programmed the robot to freeze before it comes to physical contact, because physical contact can be dangerous for the person. So the question of safety here is definitely present, and it's not something that we, when we see this kind of picture, spontaneously think about. Well, we spontaneously have read all the newspapers and think about the big questions, but there is a very simple design question and also the question of training this person. So the way digital ethics works, and we'll talk about various kinds of questions today, is not only asking these big questions, the big questions about emotional contact, and you have them there on the left hand in the upper corner. The question of imitation of life, the question of autonomy of these people. We'll talk a lot about autonomy, but also asking the operational questions. And the way this field of digital ethics, or as people say today, AI ethics, this field can be mapped is not only in terms of these big topics, big themes that you see there in the left upper corner, but also the 2 other kinds of mappings. One is the mapping in terms of agents. Who is responsible? This is very important for lawyers, and since we're not talking today about the legal part of it, I'm going to skip this, but of course, what kind of agent is responsible for what kind of issue is an important question. And finally, the classic classification of ethical issues that you see at the level of the European Union when you write your projects for Horizon Europe or for ERC, they all tell you what are the big values and principles that may come at risk in your project. And this is in terms of values and principles. Values and principles like security or fairness, which are not specific to digital ethics. There are security requirements for, I don't know, buses or trains. There are principles like loyalty or usefulness that are a little bit more specific. Loyalty, for example, for a digital system means that the system or an AI system is not doing anything that it's not reporting to the users, not doing things in the background that are hidden, or traceability and interpretability. I'm not going to define them. I'm going to illustrate them with several pictures just to give you the general map before we go into some concrete examples in the area of healthcare, and then later even into some neuroethics. So I've tried to target this to neuroethics and AI, which is, of course, what is probably most interesting for you. Now, at the European level, and I promised not to talk about the regulation and instruments, but I still need to say a few words about this. You all know probably that when you're writing a research project, you are supposed to fill in that ethics questionnaire or something. And in that ethics questionnaire, what is at work are the principles and values defined in 2019 in this document called the High-Level Expert Group Assessment List for Trustworthy AI, which is sort of the main regulatory document today. This is something that we apply at the CEA Ethics Committee also when we work on projects that are submitted to the CEA Digital Ethics Committee. And the problem here is that the big principles and values are all sound nice, but there are tensions between them. So the problem are really the tensions between principles and values, and not so much the respect of each value in particular. So let me show you some of the classic tensions that exist and that you very well know about. If you look at this kind of example, this is face recognition. Face recognition, of course, everybody immediately will think face recognition is about the tension between two different values. One is public security, and the other one is privacy. So you have two values, respect of privacy. On the other hand, you have public security. And the question is, where do you place the cursor, where do you place your pointer between the two? And the place where you place your pointer depends on the context, cultural context, regulatory context. In China, it's not the same. So you see here an example of a tension. But the reason why I'm showing you this is not to discuss anything about face recognition and the question of privacy versus security. It's rather to ask how that works. And the way it works is pretty easy. So if you know something about how machine learning works, you don't even need a very complicated network. You probably need a relatively simple convolutional network that will be either doing reinforcement learning or maybe unsupervised learning. And it will by itself define, I should say, maybe 10 to the power 2 parameters of the photographs of human faces. 10 to the power 2 parameters, something around 100 parameters. We don't have enough words in our language to name these parameters, right? We have in our languages around 20-25 terms to name facial traits. Is that a problem that you cannot say what these parameters mean? You ask the police, you go to a law enforcement agency and you tell them, well, I can't really explain. And they will tell you, well, we don't care how you explain. What we care about is whether the result is right or wrong, whether you found at the end the criminal that we were looking for, we were searching for or not. Right? So the police will not ask you how exactly that works. But now you take exactly the same kind of software, image recognition software, and you show to this image recognition software not the photographs of human faces, but radiological scans from fMRI machines, let's say, right? And that will still work very effectively, very accurately. You know that today a lot of radiologists are using these kinds of systems. So some people say I'm in the process of being replaced. Well, that remains to be seen. I don't believe in that. And in one of the projects, we will work on AI ethics for radiologists specifically next year. But here, you can imagine a dialogue between a doctor and a medical patient. So sit down, let's look at the screen. We will have the results of your test on the screen. Well, you see the result? There's some red here. I'm afraid the news are not very good. You need to undergo an operation. Well, doctor, tell me, what do I have? Well, you see all this red here. So it says you need to undergo an operation because people are dead and within 6 months they have red here. So, well, doctor, tell me what I have. Well, you see, you have red here, right? And of course, I'm exaggerating a little bit, but you see that in this use case, you have to have an explanation. The medical doctor needs to be able to put some words on this result, which is very efficient and precise for sure, but needs to be communicated with the natural language. And this is called the problem of explainability. of AS, of machine learning here, or system results. And the problem of explainability depends on the use case. You can have the same kind of software for image recognition, and there will or will not be a problem of explainability depending on the kind of use that we're making for the software. Another source of ethical tension, that was one of those, and I'm going to show you some more, is just on one slide, this classic example. I think you've all heard about these kinds of things, especially for convolutional networks. Again, you have a panda on the left, you add some 7,000 of that noise to the panda, right? You have the panda on your right. And for us, it's still a panda. For a recognition system, it's given with a 99% confidence. And the same kind of trick can be played with cars. The same kind of trick can be played with tumors. So on the left, you have an actual picture of a tumor. You add some white noise there. There's no signal, it's white noise, right? It's a classic image recognition system. On the right, for a human doctor, it's still a tumor. For the system, it's not a tumor anymore. Your confidence rates falls down. So this is called the problem of robustness. So artificial neural networks are typically not robust if you show them some signal that they had never seen during their training. And the kinds of ethical tension I'm talking about, or rather the sources of ethical tension, there are 5 of them. I talked very quickly about explainability and interpretability, which is number 3. I showed you on one slide the instability and lack of robustness, which is number 4. Lack of robustness is sometimes a problem and sometimes a feature. Sometimes you want it, if you are creating a chatbot, you want it to not be stable, because otherwise it's going to give the same answer all the time, right? If you are creating an image recognition system, you want it to be stable. So it's not something that is always a problem. Sometimes you want to not have robustness. And then the bias and non-discrimination, which I'm not defining. I think you've all heard. I don't need to spend time talking about bias in data sets and the way systems reflect that bias in the results. But we'll see that in a couple of examples. So this is the picture from the point of view of the engineer. Again, another mapping of this digital ethics. And what do we do in digital ethics? Well, the European Union tells us, here is a checklist for you, 150 questions, 150 questions. Have you ever seen an engineer or a researcher who is asking themselves 150 ethical questions when they are designing a research project? I've never seen somebody who's spending time on 150 questions. So this is very nice. And this new checklist called Altai is not quite useless, but it's not very operational. So what we are trying to do is to go as operational as possible on concrete projects. And I will show you this example from a research project called iRECS. It's a European project in which Bernadette participates also, by the way. And in this project, we've done, among other things, we have looked at AI ethics for healthcare. And we said, well, okay, we want to create a tool that is really helpful for researchers, something that they can take and get an idea of what kind of questions should not be forgotten. So in this project, we, instead of 150 questions, we came up with just 2 pages. There are 8 categories of issues, 8 categories of questions. And we're giving this 2 pages checklist, again, a checklist, to researchers, telling them, please go through this and see if some of these questions are really serious in your project. So this is a tool that is designed to be helpful for researchers. For example, in my project, bias may be a big issue. And somebody will say, oh, in my project, I'm giving this to actual doctors for working with patients, so I need oversight. I need human oversight from medical doctors. How do I design oversight? And so on and so forth. So I'll show you an example in a second of how this works. And we do this just for those of you who are organizing different kinds of activities here at Neurospain. We do this in short 3-hour trainings when we talk about AI in healthcare. We also do with my postdocs long courses. Here's an example of an 18-hour course in research ethics and AI ethics. So we have different formats that we offer across CA to different groups. We've been doing this quite a lot for computer scientists at LIST and for other people a little bit. So if you're interested in short, long, or other kinds of trainings, you're very welcome to reach out. So let's look at this example. Here is a simple project, which is summarized here. You give an app to people who have depression. So people have depression. They return, maybe they went to the hospital and they return home. Maybe not. Maybe they just went to see a psychiatrist, a doctor, and you give them an app to do the follow-up after medical treatment, right? And this app, is supposed to follow up the state of the patient, to talk to the patient, of course, and to give advice in some way. So the app will rely on predictive models from machine learning with both retrospective and prospective data. So there's clinical data, and then there is also social data. This app apparently will have access to the person's social networks and whatever is going on the phone. All of this data collected will be used by the app, but also is made available to mental health practitioners. I'm telling you about a research project. It will use unsupervised learning. I don't know if I need to define, everybody here has an idea about how machine learning works in general. Unsupervised learning meaning that there are no human annotators behind. So you just give data and you ask the system to come up with some results, some analysis of that. The app will identify the patient's needs, including unexpected needs, and provide specific advice and decision support. So there is a chatbot, right? It's psychology. It will use an external large language model to make sure that the language is clear, well formulated. So the formulation of messages goes through an external model. And then the app may discover unknown effects. And here is an example, of course, a very short one of a project that can be submitted to an ethics committee, or simply as a researcher, you may be building an app like this. And now, how do you even go through the ethical analysis of this? So, of course, you take these 2 pages of the checklist that I told you about, which we're not going to do right now, and you start thinking, well, I have a data set, so I need to work on the data set. To make sure that there is no bias. I have privacy issues because I collect this data and make it available to mental health practitioners. So how about the consent forms and the usual procedures for privacy and human participants? Then you think, okay, do I have cybersecurity issues? Do I have explainability issues? What am I going to work on? Because it seems that there are so many different issues. And the checklist is supposed to help you to focus on questions that are the most serious and complex ones. So cybersecurity here is definitely an issue. Can you see it? If somebody, because there's a language model there, if somebody is doing prompt injections and trying to induce some misuse of that language model so that the advice given to the person won't be adequate or correct. Right? So how do you protect against injections, prompt injections in the language model? Actually, you've all tried ChatGPT with different prompts, and you know that you can try to destabilize the system quite easily. So it depends on the language model. But another thing that you find out using this checklist, for example, is that, well, because there is non-supervised learning, maybe there are specific questions because of this type of machine learning. What kind of questions? And if you're not an expert in digital ethics, you will say, okay, well, I don't know, how do I find that out? And the checklist will tell you, sure, if you have unsupervised learning, you have an issue of explicability, of explainability. That's what we've just talked about on the example of face recognition. There is a problem here for explicability for the results with low scores. So if you have a low confidence score, do you show this to the patient? Do you have another model that will be evaluating whether this is a good answer or not? So you see, this checklist doesn't give you instructions on how to build the model. This checklist will help you to ask the right questions and to evaluate, if possible, whether these questions are serious or not. And then the job of ethics committees, what we do is really to help the researcher find the interesting questions, not so much provide the answers, because that's what the researcher will be doing themselves. And in a new project that we will be running called AIOLIA project, running starting this February, including some researchers from Neuroscientists, we will be trying to go on this very operational level on different use cases. So we will be creating guidelines and then training people. Once again, there will be more trainings. And here it's about ethics of AI and human cognition and behavior. So I will, in the second part, show you some very hard questions, ethical questions about AI and human cognition that we don't really know how to answer. But here in the AIOLIA project, we will try to create these kinds of operational approaches, very concrete guidelines that can help AI researchers to come up with interesting questions. And there will be several use cases. So if you're interested, this begins in February, and we will definitely try to do some useful and interesting work for researchers in this project. Now, what I'm going to talk about now is one of these difficult problems, but I'm going to take a long way to arrive at this difficult problem. And my journey to the difficult problem begins with the law that we have these days. I'm not sure you have heard about this, but since this summer, so since last summer, we actually have a new law in the European Union. It's a regulation called the AI Act, Artificial Intelligence Act. And this regulation begins in Article 2 by saying it doesn't apply to research. Only when you put a product on the market does the law apply, but not research. But again, do we actually do a lot of research that never goes into systems that people use in real life, that never goes on the market? Well, there's a big gray zone here. And the gray zone is currently being discussed. We don't know exactly what's going on in Brussels. There are a lot of discussions whether research organizations should follow or should not follow this law. We'll see. One of the open questions for us at CA and also for you at Neurospin, you will see, is the question of bans. This law says there are certain types of AI systems that are prohibited in the European Union. And this forbidden part will enter into force in February. So in February, the bans will apply. There will be some types of AI systems that are outright forbidden in the European Union, except that we don't really know how to define what's forbidden and what's not. And here's one example which now brings me to the difficult problem. Article 5 in the law says the placing on the market, putting into service, or the use of an AI system that deploys subliminal techniques beyond a person consciousness or purposefully manipulating or deceiving techniques is forbidden. And then there is an explanation there in the law. And you will see how political this is and how disconnected from research this is. An explanation in the law that says AI systems deploying subliminal components, such as audio, image, video, beyond human perception, or other manipulative or deceptive techniques that subvert or impair persons' autonomy, decision-making, or free choice in ways that people are not consciously aware of are forbidden. Or even when people are aware of them, they can still be deceived or not be able to control or resist them. That's forbidden. And there are examples in the law. It actually cites brain-machine interfaces or virtual reality. And right now we have a working group at the Academy of Science and the Academy of Medicine where we're trying to work out the ethics of BMIs, the ethics of brain-machine interaction, and say, well, what's going on here? It doesn't mean that everything is forbidden, for sure. But what exactly is going on in this law? You see, there are so many terms that are not quite clear. Person's autonomy, free choice, beyond perception, that you guys know from neuroscience that these things don't go by themselves. I mean, these are problematic concepts. And let me remind you, I'm switching to part from another talk based on a recent paper with a colleague. Let me remind you what is problematic about these things. And this is something that I think we all should be thinking about together. So in that other project called Tech Ethos, we looked at various techniques in neurotechnologies. You know this better than I do, DBS and so on and so on. We looked at various applications that have also, of course, ethical issues associated with these different sectors and applications. So criminal justice, the question of responsibility, or so on and so forth. In this project, we have also looked at the European values and principles that I've been talking about. So you see, when you're doing this project in ethics, you need to talk at different components from different angles. First, what are the techniques? Second, what are the applications and the sectors? And finally, what are the values? And what we see, and I'm coming to my discussion on autonomy here, what we see is that all the legal texts put autonomy as a value, human autonomy as a value. But what exactly is autonomy? One way, of course, will be to connect autonomy with free will. But then which is a rather standard way of doing this, but then for free choice, if you like. But then there are questions of BCIs, for example, that make decisions beyond awareness, that humans are not consciously aware of. And when you are designing a BCI with an AI component, the question is, what do you do with that? You know that these kinds of decisions exist. You know that there is machine learning on brain data. And does it subvert human autonomy? How do you even decide that? One simple way opt-out is to say, I'm just going to give you a red button. If you don't like it, you push the red button, it stops. Is that a solution by design that isn't sufficient or enough? And the law says, no. Even if you are aware that these things exist, maybe it will still be open to manipulation in some ways. So to go into this discussion a little more deeply, we need to think about free will not as an absolute value and not as an autonomy as absolute value. We need to think of them in the larger context of what is a human person. So how do you even define human identity in that context? And this brings us back to the discussion in the philosophy of cognitive science that I think you are well aware of, I hope so, going back to the 50s. So this famous argument by Elizabeth Anscombe, who said, intention, in the book Intention, she said, intention is a mirage. Intention, desire, and will, says Anscombe. And remember, this is 1950s, way before modern technologies, right? Anscombe says, intention is a redundant description. We need causal power. And it's not intention or desire that have causal power. So in her book in the 50s, and this is the beginning of the modern discussion in the philosophy of cognitive science, she says, it's enough to say that an agent knows or believes that C has, and this is a core of some action S, right? So you don't need to formulate desires or wishes of agent A, you need to go into causal descriptions. And this is, of course, connected with a classic, very classic debate on Libet's experiments. So you all know, I guess, from your classes in neuroscience about Libet's experiments and the readiness potential. You know that the readiness potential has been questioned by people working in this very building, right? So in 2012, Stanislas Van and Holm and collaborators questioned the idea of readiness potential, but you remember the problem of readiness potential. If there is a readiness potential before an action comes to the person's awareness, conscious awareness, can we say that that readiness potential arising as a neural signal in the brain causes action, and the question of awareness becomes redundant in that case? And this was one reading of Libet's experiment. Libet himself was actually in favor of free choice. He said, no, that was not the right reading. And here people at Neurospin 15 years ago seem to say that we still can save some kind of argument about the existence of free choice. But then came the split brain experiment. So I'm reminding you about the basics of what you probably have learned in your master's or PhD years. The split brain experiments are about perception. We have here the brain that is split in two, and you can show something to the left side or the right side and ask the other side of the brain or the same side of the brain to report. And you will know, there are examples also from 10, 15 years ago, that beyond human perception is a very problematic notion, because what exactly is human perception? Which part of the brain is perceiving what? You can have a situation when the subject cannot report verbally, but can draw an image. Is that human perception? You have some situations when half of the brain is aware and the other half is not. Is that human perception? So there are experiments in neuroscience that put into question profoundly the concepts that today are used in a law that governs artificial intelligence in the European Union. And that's why we need people with expertise in neuroscience to come and join us in these discussions on ethics and AI regulation, because the concepts like human perception, free choice, autonomy should not go for granted. The way they are today in the law, without definition, sort of everybody understands what they are. Well, it's not true. So to conclude, maybe my last two slides, we can go one level further. And here I really put away all my administrative functions, Brussels committees, and so on, and I returned to the state of being a philosopher of science. So when we think about autonomy and free will, we, as I said, need to think about human identity and human person and what defines that person. And that question has two types of answers in the tradition. In philosophical first, then scientific tradition in the last centuries of Western science. And these two kinds of traditions are dualism and monism. So there are dualist answers that somehow will separate mind and body. The mind-body problem will have a dualist interpretation. And so causal powers will be given to both the mind and body. And then there are non-dualistic ones. And what I would like here to suggest is that it's still possible to talk about perception, consciousness, awareness as notions that neuroscience can deconstruct and put into question on an account which is not a dualist account, but which preserves human responsibility. So this is something that in ethics is not straightforward. Can we deconstruct scientifically perception, free choice, consciousness, awareness, show that these are problematic notions and still talk about responsibility? How do we do that? And here I will very quickly quote a position that one of my teachers, Ariadne, has been promoting for the last 40 or 50 years. And this position is fundamentalist Spinozist. It doesn't mean that I agree completely with the Spinozian account, but what is very interesting is that Spinoza is not a dualist, unlike Descartes, right? And Spinoza says men believe themselves to be free simply because they're conscious of their action and unconscious of the causes. But the causes, and we can translate this into modern language, the neurophysiological causes of action, are the two aspects of the same thing. In the way Spinoza says, mind and body are not two different realities. You don't need to separate them, but these are two aspects of two different descriptions of the same natural process. And what does this give? Why do we want to read Spinoza, and why do we want to use this kind of account when we have to think about the problem of autonomy and awareness? Well, this brings us to, and this is one last step that I want to make, to a story which is even older than Spinoza. And this is the last story that I will tell you. In a very old book written about 2,000 years ago, of commentary on biblical verses, whatever that book is, it's called the Answers of Fathers, if you like. In this Jewish book, there is a very, very enigmatic phrase that I've been trying to think about. And the phrase is, everything is foreseen, but the permission is given, or freedom of choice, or freedom of will is granted. And how come everything can be foreseen? So you can have neurophysiological determinism of things like the readiness potential, and yet there is a freedom of choice. How can you reconcile these two notions? And the answer here is that it's reconciled at the level of responsibility. So even if there is causal determination of action, the notion of autonomy is altered. It's not the same notion of autonomy if you admit causal determination of action. So freedom of choice becomes something that can be neurophysiologically seen through signal, through something like a readiness potential. But it doesn't mean that this removes responsibility. The subject remains responsible, even if this freedom of choice is a high-level illusion in a way. So this is the kind of problem that I think goes, as you see, very deep in the history of philosophy and history of thought, with Spinoza, with these Jewish texts from 2,000 years ago. But this is something that we see today in a very operational way when we need to interpret a law that we have in 2024. Because the law uses concepts that don't go for granted and that need to be thought through with the help of both modern neuroscience, which will put into question whether these concepts actually make sense, and all of the tradition of philosophy, which will hopefully be able to restore some of that context of responsibility that we need to restore to be able to put AI systems out there and to let people work with AI systems, because the questions of responsibility need to be defined. So you see how in the work we're doing, there are all these different dimensions: the institutional dimension, the regulatory dimension, the scientific dimension, and also these quite deep philosophical dimensions that suddenly come to the surface and become very, very, very up-to-date questions. So I'll conclude with that, and thank you for your attention.